Welcome to the DIY Honda Garage channel. The DTC P0101 pertains to a mass airflow (MAF) sensor circuit range performance issue commonly found in the 2023 Honda CR-V. When the powertrain control module (PCM) detects that the output frequency from the MAF sensor is out of the specified range or the signal is abnormal, it triggers this diagnostic trouble code. The MAF sensor plays a crucial role in measuring the amount of air entering the engine. This information is vital for the PCM to determine the correct air-fuel mixture needed for optimal engine performance. If the air-fuel mixture is incorrect, it can lead to poor fuel efficiency and increased emissions. Located typically in the intake air system, right after the air cleaner assembly, the MAF sensor can be affected by several variables, including wiring issues and blockages in the intake system. Addressing DTC P0101 quickly is essential to maintain vehicle performance and ensure compliance with emission standards. DTC P0101 indicates a mass airflow (MAF) sensor circuit range performance problem, meaning that the output frequency of the MAF sensor is out of the expected range. The MAF sensor is essential for proper air metering, directly influencing engine performance and combustion efficiency. It specifically communicates the volume of air entering the engine to the powertrain control module, PCM, which adjusts the fuel injection accordingly. The PCM continuously monitors data from the MAF sensor to ensure that it operates within specified limits. If the frequency deviates from the set parameters, the PCM identifies this as a malfunction and stores the DTC. This situation can stem from various issues, including sensor failure, wiring problems, or obstructed air intake components. Understanding the role of the MAF sensor and its placement within the air intake system helps in effectively diagnosing and troubleshooting this DTC. Several potential causes could lead to the triggering of DTC P0101, each affecting the MAF sensor's ability to provide accurate information. First, a malfunction or failure of the MAF sensor itself could distort its output frequency, leading to erroneous readings. Second, any wiring issues, such as frayed wires, poor connections, or corroded terminals, can prevent the sensor from functioning correctly or providing accurate data to the PCM. Lastly, blocked intake pathways, including obstructions in the air duct or issues within the air cleaner housing, can restrict airflow and create a false reading at the MAF sensor. Each of these potential causes must be methodically examined to efficiently resolve the DTC and restore proper vehicle operation. By systematically focusing on these areas, technicians can accurately identify the root cause and address it accordingly. The symptoms associated with DTC P0101 can manifest in various ways, reflecting the impact of MAF sensor issues on overall vehicle performance. One primary symptom is poor engine performance, characterized by reduced power or sluggish acceleration, often due to an incorrect air-fuel mixture being delivered to the engine. Another symptom may be increased emissions, as an inefficient combustion process leads to the generation of harmful pollutants that exceed emission standards. Lastly, drivers may notice a significant decrease in fuel efficiency due to the engine compensating for erroneous airflow data. Collectively, these indicators can lead to a less than optimal driving experience, highlighting the importance of addressing DTC P0101 promptly. Ignoring these symptoms can lead to further damage and increased repair costs, making early detection and resolution critical for maintaining vehicle health. The first troubleshooting step for DTC P0101 is to start the vehicle's engine and then hold the RPM at 3,000 without any load, whether the vehicle is in park or neutral. This process allows for a consistent evaluation of the MAF sensor's functionality under a controlled engine speed, which is crucial for accurate readings. You should maintain this RPM until the radiator fan engages. Then let the engine idle for at least 5 seconds. This procedure tests how the PCM interprets data at a specified RPM, providing insight into the performance of the MAF sensor. If the PCM detects that the MAF sensor output is still beyond the acceptable range during this test, it likely indicates a malfunction with the sensor or related components. Clear and accurate outputs during this step are vital, as they determine the next steps in the troubleshooting process. In the second troubleshooting step for DTC P0101, the vehicle should be driven at a steady speed of 37 miles per hour, approximately 60 kilometers per hour, for a minimum of 5 seconds. This phase allows the MAF sensor to provide real-time data during normal driving conditions, ensuring that it accurately reflects airflow into the engine. Maintaining a consistent speed is crucial because fluctuations in speed can lead to variable air intake readings, complicating the assessment of sensor performance. As the vehicle operates under these conditions, the PCM continues to evaluate sensor outputs to verify that the MAF sensor readings are within the expected parameters. If the readings during this test remain abnormal, it reinforces the suspicion of a MAF sensor issue or possibly other intake system malfunctions, which could affect overall performance. The third step in troubleshooting DTC P0101 involves a thorough inspection of several components related to the intake air system and positive crankcase ventilation (PCV) system. Begin by examining the PCV valve and its accompanying hose for any signs of damage, blockages, or operational failure. A malfunctioning PCV valve can negatively affect engine performance and skew MAF sensor data. Next, inspect the purge line condition to ensure that it's not leaking or blocked, as issues here can also cause erroneous airflow information. Furthermore, evaluate all components from the turbocharger joint to the throttle body to check for proper connection and functionality. Any abnormalities identified through these inspections point toward potential failures in the intake air system, which can directly impact the MAF sensor's readings and contribute to the DTC being set. The fourth troubleshooting step for the DTC P0101 requires a detailed inspection of the intake air duct and the air cleaner housing. The aim is to identify any blockages, restrictions, or damage that could interfere with airflow to the MAF sensor. Start by inspecting the intake air duct for faults like cracks, leaks, or obstructions that could disrupt the airflow dynamics, which is crucial for accurate MAF readings. Next, assess the air cleaner housing, ensuring that the air filter is clean and properly installed. Blockages in either components can lead to an incorrect volume of air entering the engine, throwing off the air-fuel mixture and potentially leading to the MAF sensor triggering a fault code. Normal conditions at these points are critical for the effective operation of the entire intake system and for the car to function optimally. For the fifth step in troubleshooting DTC P0101, it is important to confirm the MAF sensor readings using the Honda Diagnostic System, HDS, while the engine is in a stopped condition. This initial test isolates the sensor's readings, focusing solely on whether it produces expected data under no load. The normal frequency range for the MAF sensor is between 520 to 10,000 Hz. Any readings falling outside of this range suggest an issue with the sensor itself or its wiring. This diagnostic procedure is essential for pinpointing whether the MAF sensor is functioning correctly before further assessments are conducted. Ensuring the sensor's data aligns with established norms is a critical step in troubleshooting this DTC effectively. Should the readings be abnormal, the next task is to check the sensor and its connections systematically for issues. The final troubleshooting step for DTC P0101 involves starting the engine and allowing it to idle, followed by confirming the MAF sensor values again using the Honda Diagnostic System, HDS. This test is performed to validate that the MAF sensor is providing accurate readings while the engine operates under idle conditions. Similar to the previous inspection, the normal frequency range for the MAF sensor should be between 520 and 10,000 Hz. If the HDS indicates readings outside this range, it indicates a problem with the MAF sensor or its assignment to AIT sensor 1. It's crucial to examine the functional aspects under varying engine conditions, as they can provide more comprehensive insight into the sensor's reliability and potential issues. Documentation of these results will guide further repairs or component replacements, ensuring the vehicle is returned to optimal operational status without compromising performance. After completing all required repairs related to DTC P0101, it is important to verify that the repairs were effective. Start by ensuring that all components pertaining to the MAF sensor and surrounding systems have been corrected or replaced as needed. Following this, it is crucial to clear the DTC using a compatible diagnostic scanner. Once the DTC has been cleared, perform a test drive of the vehicle under various driving conditions to confirm that the issue has been resolved and the MAF sensor operates correctly. During the test drive, observe any potential symptoms that might have previously been present, using the systems monitored by the PCM. Assurance of proper functionality is vital before returning the vehicle to the owner, as this final step guarantees that both performance standards and emission regulations are met. Preventive maintenance is critical to preventing future occurrences of DTC P0101 and ensuring the longevity and efficiency of the vehicle. Regularly checking and replacing the air filter can prevent debris and contaminants from reaching the MAF sensor, thus ensuring it accurately measures airflow. Additionally, it's important to routinely inspect all connections related to the MAF sensor for signs of wear, corrosion, or loosening, which could lead to airflow discrepancies. Maintaining the entirety of the intake system, including ensuring that there are no blockages in the intake ducts or housing, can greatly enhance the longevity of the MAF sensor's performance. By incorporating these preventive measures into routine vehicle maintenance, owners can drastically reduce the risk of similar issues arising in the future, ensuring smoother engine operation and improved fuel efficiency. In conclusion, understanding DTC P0101 and the role of the mass airflow sensor is pivotal for the effective maintenance of the 2023 Honda CR-V. The MAF sensor is vital for providing accurate airflow data, which the PCM relies upon to balance the air-fuel mixture essential for optimal engine performance. Recognizing the various symptoms, including poor performance, increased emissions, and decreased fuel efficiency, allows owners and technicians to respond promptly. Detailed inspections of the MAF sensor and intake systems play a crucial role in narrowing down potential causes. Following a systematic troubleshooting process not only aids in resolving the DTC, but also prevents similar problems in the future. Ultimately, proactive maintenance strategies are beneficial in enhancing vehicle functionality and ensuring compliance with emission standards. Please like and subscribe to the channel. See you next time.